Okay, today we are going to talk about simplifying, multiplying, and dividing fractions. And the main thing to remember with these is that you can cancel out diagonally and you can cancel out vertically, but you cannot cancel out horizontally. It doesn't work that way. So let's go on to our first example here. And our fractions, since we are in an advanced course, they have some variables. So I have some x's and y's, excuse me. And I'm going to look at this. Like I just said, I can cancel out horizontally. I can't cancel out horizontally, but I can cancel out vertically and diagonally. So the first thing I want to look at is what do these things mean? Some of you can do this in your head, but some of you may need to write it out. So here I have 4 and x cubed. That means I have 3 x's over 3 and y to the 4th, so 4 y's. And then 9, I'm going to write as 3 times 3 because, again, my goal is to be able to cancel. And y squared means I have 2 y's. Then 16 is 4 times 4 with my goal of canceling. And I have 2 x's. So now when I look at this, I can cancel out anything 1 for 1. So I have 1 4 here, I can cancel 1 4 here. I have 2 x's here and 3 here, so I can cancel 2 of them. I can cancel one of these 3's with this 3, and since I have 2 y's, I can cancel 2 y's. So that will leave me with an x on top, a 3 on top. And since you're multiplying, you can just put those together. And then on the bottom, you have 2 y's and a 4. So I'm going to write that as 4y squared. Okay, example 2 is an example of just simplifying. And you can't just cancel things that are look-alike when there are pluses or minuses. So you have to factor. And so the top of this has a GCF of 3x. And if I take that out, that leaves me with x minus 3. And then on the bottom I have x minus 2. And nothing here cancels. And so you do sometimes need to check it to make sure that nothing cancels, but you occasionally have a problem where you can't do anything with it, and it's best just to leave it as it was in the beginning. Okay, so now let's say, for instance, that instead of this 2 on the bottom, it was a 3. So if my original problem had been 3x squared minus 9x over x minus 3. Obviously, when I factored the top, it would still be the same. And I would have the 3x times x minus 3. My x's keep disappearing. This x minus 3 on the bottom, even though it's not in parentheses, that's okay. If you want to, you can put it in parentheses. But I can actually cancel these now because between the 3x and the x minus 3, it's considered multiplication. And so they're multiplied. I'm allowed to do this. So just a slight difference can make the problem a little bit more workable. My answer in that case would just be 3x. Okay, let's move on down to our next example. This one going to take a little bit more work because obviously this looks like stuff we factor. This is also a division problem, so that brings in one extra step. If you remember in elementary school, when they taught you how to divide fractions, they taught you to flip and multiply. And that's what you do. You flip the second fraction and multiply, the one that comes behind the divide. But I'm going to go ahead and factor because we have to do that anyway. And this is a trinomial, so this is your x factor. And you have your x, you got your negative 15, and your 2, what multiplies, and that would be a 5 and a negative 3. So that would be x plus 5 and x minus 3. And on the bottom, I can factor a 2 out as a GCF, so 2x minus 4. This is getting annoying. All right, like I said, when you're dividing by a fraction, you want to flip and multiply. So I'm going to go ahead and flip and factor at the same time. I'm going to change that divide sign to a multiply. I just have to remember to flip. So I'm going to go ahead and factor this bottom, but I'm going to put it on top since I'm flipping. This is your difference of perfect squares. So I have x minus 4 and x plus 4. Then with the top, it's now going to factor to the bottom, and it's our x factor, trial and error factoring, trinomial factoring, and I have my negative 12 and an understood 1, so positive 1, and that would be a negative 4 and a positive 3. Excuse me, a positive 4 and a negative 3 because I need a positive 1. So I have x plus 4 and x minus 3. Okay, so now I can get to canceling. And again, vertically and diagonally are legal. So I can cancel this x minus 3 and this x minus 3 because they're diagonal. I can cancel this x minus 4 and this x minus 4 because they're diagonal. I can cancel the x plus 4s because they are vertical. They're on top of each other. And that leaves me with just x plus 5 over 2. Take note that this could also be written as 1/2 x plus 5/2 if you were needing to do it. Okay, I have a couple more examples that are a little bit more complicated. This one has 3 fractions that we're trying to work with, but you still have to remember the order of operations, and the order of operations says that we do anything inside parentheses first. So I'm just going to bring down this outside part and not mess with it for a minute. And I'm going to work on this inside parentheses. So I have a fraction divided by another fraction, which means I'm going to flip that second one and multiply. So x plus 3 is going to go on top, x plus 2 is going to go on the bottom. And nothing's going to cancel here, but I can put these together. So I'm going to leave some space for this. I'm going to put this together to have x minus 3 and x plus 3 on top, and x minus 1 and x plus 2 on the bottom. Okay, now I'm going to come over here to this first one, and I'm going to factor it. And so I have x minus 3 and x plus 3, because that was a difference of perfect squares, over x plus 2. Okay, because this has a divide, we need to go one more step, and it's this fraction divided by this fraction, so I need to flip the second one and multiply. So I have x minus 3, x plus 3 over x plus 2. That one's not changing, but I'm going to change to a times, flip the second one. So the x minus 1 and the x plus 2 go on top. The x minus 3 and the x plus 3 go on the bottom. And now I can cancel. So the x minus 3's cancel, the x plus 3's cancel, and the x plus 2's cancel, and this whole thing becomes just x minus 1. Alright, we move into our last example. And here's where all my x's jumped to. Okay, in this last example, we have a lot of factoring. You'll notice this has 4 pieces and this has 4 pieces, so that's going to be factored by grouping. So I'm going to go ahead and give myself some room. And this is just a times, so I don't have to worry about flipping anything. Alright, I'm going to group the first 2 up here and take out a GCF, which leaves me with y plus 2. Then I'm going to group the second 2. The GCF here would be a negative 2. Once I take that negative out, it's going to leave me with y plus 2, as it should. And then I'll come down here to do that last step. I'll need some more room. And the last step is looking at that as my common factor, taking it out, and that leaves me with what's in front, which is the x minus 2. So there's my factor by grouping. Now the denominator on this one is going to factor to 2 parentheses, and I'll just go ahead and do it down here. And it's your x factor. So you're looking at what multiplies to give you 3 and adds to give you 4, and that's a positive 3 and a positive 1. So you have x plus 3 and x plus 1. Over on this side, I again have factor by grouping, but this time it's on the bottom. So I'm going to group these and group these. My GCF of the first piece is x. That leaves me with y plus 3. My GCF of the second is -2. That leaves me with y plus 3 again, as it should. And then that becomes my common factor. So I write that one down, y plus 3. And that leaves me with x minus 2. The top is going to factor, again, x factor, trial and error factoring. It's what multiplies to give me a -3 and adds to give me a 2. And so that would be a +3 and a -1. So I have x plus 3 and x minus 1. Then I can cancel x minus 2's and x plus 3's, and I think that's it. Now, because it's multiplying, I can just basically collect everything from the top. I have y plus 2 and x minus 1. On the bottom, I have left an x plus 1 and a y plus 3. That concludes this lesson. If you have any questions, just raise your hand.